Hello children and welcome to your channel Sharda Educare, and in this video we will be learning property of the three parallel lines and their transversals. So before we begin, we will first perform an activity and then we will prove this theorem. Children, you can see here I am going to draw three parallel lines. This is one line and parallel to this is another line. Let me label this line as L and this line as M. One more line I will draw. I am using a scale and exactly below after line L I drew the line M because I wanted three parallel lines. Okay. So this is L, this line is L and this line is M and this line is N. Now I will be drawing one transversal here and name it as T1 and another transversal other side and name it as T2. So these are the two transversal and these are the three parallel line. Now wherever transversal T1 cuts line L, where it cuts line L, label it as A. Where T1 cuts M, label it as B, that point should be B, N is C. And T2 cuts line L at D, at E and at F. Now we will measure the intercepts. You can see children here, this intercept is this intercept. This is known as intercept. Intercept means the portion of the transversal between line M and between line L. This intercept, what is the length of this intercept? It is 2.8. This is 2.8. Let's go for this. This is also 2.8 children. Let's go for this. Yes, even this is 2.8 and of course this will be also 2.8. So what we are getting, if I write AB upon BC, which is 2.8 upon 2.8, if I cut it, I'll get 1. This is my first statement. DE upon EF, this is 2.8 and this is also 2.8. If I cut, I get 1. That means, this is my second statement. That means AB upon BC, AB upon BC is equal to DE upon EF. Now we will be proving this ratio of the intercept made on a transversal by three parallel lines. So I will draw three parallel lines, children. You have seen in the activity. This is the three parallel L, M, for a transversal. So let me draw a transversal here. And this transversal is T1. T1 is cutting L at A, M at B and N at C. So ratio of intercept, this is intercept children and this is another intercept. So this upon this. So ratio of intercept made on a transversal by three parallel line. is equal to the ratio of the corresponding intercept made on any other transversal. This is one transversal. I will draw other transversal, that is T2. So when I draw another transversal, again I get the intercepts. So ratio of the intercept 3 parallel lines on a transversal is equal to the intercepts which are made on the other transversal by the same parallel line. So this is the corresponding intercept. Okay, let us say T2 intersect line L at P, line M at Q and line N at R. So the intercept made by LMN on transversal T2 is PQ and QR. So what we want to prove, they are equal, means the ratio of this is equal to ratio of this two. Fine. Let's begin with what is given. First I'll write here given. Given is what? Line L is parallel to M is parallel to N. Means all the lines are parallel to one another. And T1 is transversal. Okay. Transversal. Intersecting the line L. Intersecting L at A, M at B and N at C. Okay, N at C. Fine. T2 is another transversal. T2 is also transversal. This intersect line L, L at P, M at Q and N at R. C. T2 intersect point L, line L at P, line M at Q, line N at R. Okay, fine. So construction we will do, children. Construction. Join CP. Join CP, and what we want to prove, let me write here proof. To prove is AB upon BC is equal to PQ upon QR. This is what we want to prove. Let's begin. We have already joined CP. So I will take triangle ACP. Okay. First statement, solution in triangle ACP. You look this triangle ACP. Line, okay. Join CP. CP cuts the line M at, let's say, D. Okay, fine. So in triangle ACP, BD is parallel to AP. Yes, because L is parallel to M. Given na? L parallel to M is given, therefore BD will be parallel to AP as APL are collinear, BDM are collinear. Fine. So we can use BPT theorem here. See, this is the triangle. Let me draw this triangle here like this. Yes, this is the line B and this is D, this is A, this is P and this is C. If this line is parallel to this, we can say AB upon BC is equal to PD upon DC by BPT, basic proportionality theorem. In the previous video I have explained BPT theorem. So this upon this is equal to this upon this. So we can write it here. Therefore, AB upon BC is equal to PD upon DC by BPT theorem, and this is your first statement. Okay. Now third, in triangle PCR, let me draw that triangle here. PCR, M, this is M, line M, and intersecting at D, and it is Q. Same figure I drawn. PCR, you can see children, PCR at D and Q. So this line is parallel to this, already we have, it is given, this is N line. So we can use BPT here. So what will be BPT theorem? PQ upon QR is equal to PD upon DC, because line M is parallel to line N. So let's write it here. In triangle PCR, M is DQ is parallel to CR. Why? Because M is parallel to N given. No? Therefore, we can use BPT theorem and we get PD upon DC is equal to PQ upon QR, PQ upon QR by BPT theorem. Okay, this is your second statement. Now compare this to statement second and fourth. See, AB upon BC is equal to PD upon DC. PQ upon QR is also PD upon DC. So can we say that these two will be equal to one another? Yes, of course we can say. In fifth statement, we can say that AB upon BC is equal to PQ upon QR. From which statement? From first and second. So hence proved that the intercepts made by the three parallel lines, this is one intercept, this is another intercept, the ratio of these two intercepts is equal to ratio of other two intercepts which are corresponding to the one. Okay. So watch the video children, rewind it, pause it again and again, you can watch and learn. So pause the video children and learn the theorem very well so that it will help you to solve the sums based on this theorem. So you must like, subscribe and share and also comment. Thank you children.